this is from the 1.5 worksheet. I have a question for you. My question is, where is this function differentiable? Does anyone have any good answer for this? If you could either type your answer in the chat box, or you can just say it out loud and mute yourself. Does anybody have any feeling as to where this is differentiable? Or you could even tell me where it's not differentiable. No feeling. Sharon messages me privately. She says it's not differentiable at 0. I agree. I agree, Sharon. Good work. Can you say why it's not differentiable at 0? Or can anyone say? Limit doesn't exist. I agree with that as well. I was wondering if she was going to say it's not continuous because, right, if it's differentiable, it's automatically continuous. So in this particular graph, since it's not continuous, that means it can't be differentiable. So, you know, you could think of, what's a good analogy? Let me go back here. When we say differentiability implies continuity, it's like, you can think of continuity as like your Chinese. No, continuity is like your Asian. Differentiable is like your Chinese. So if you're Chinese, that implies that you're Asian. But if you're Asian, that doesn't necessarily imply you're Chinese. You could be Japanese, you could be Indian, you could be Korean, you could be Vietnamese. So it's like one is more general than the other. One is like a stronger statement. Okay. So if it's not continuous, it's automatically not differentiable. So Sharon is absolutely correct. It's not differentiable. A lot of times I'll write diffable instead of differentiable because it's just less writing. So it's not differentiable at x equal to 0 since it's not continuous at x equal to 0. Does that make sense? So let's look at further up in this worksheet over here. Look at this example 5 graph. Where is it not differentiable? I hope you guys can see it's the same thing, right? It's not continuous at 0. So at 0, it's not differentiable. Okay. Let's take a look at another. Where is this graph not differentiable? I hope you could see it's not differentiable at -2, sorry, because it's not continuous there. It's not differentiable at 1 because it's not continuous. It's not differentiable at 3 because it's not continuous. It's right there and not at 1. Okay. So these graphs are okay, but I wanted to show you something more interesting. So I'll have to make up an example. So let's take a look at this example. Just so you guys get the idea. Here's 0, here's 1, here's 2, here's 3, here's 4. And let's draw a graph like this. Okay. The question is, this is the graph y is equal to f of x. The question is, where is f of x not differentiable? I want to play 3, 2, 1, go. So take a second to type your answers in the chat box. You know, which ones are not differentiable. You can just type it out. And then we will count it down. So take a moment to type your answers. And let's do this. Ready? 3, 2, 1, enter. All right. All right. So I got a lot of answers that I expected. No one has gotten the question completely correctly. So if I tell you that not all of you got it completely correct, does anyone want to modify their answer? No. 0 is fine, Ken. 0 is fine. So let's take a look. First of all, definitely 1 is a problem. Aaron, that's right. 1, 3, and 4 is the right answer. So 1 is a problem. Why is 1 a problem? This is when you have a cusp. A cusp is an issue because if you look on the left here, if I were to guess what the slope was, I mean, they didn't even label the y-axis, so I can't really tell. But to me, that looks like a -1, a slope of -1, maybe -3/2. But if you look at the right-hand side, this slope kind of looks positive, right? So you come from the left, you're getting to get a slope of like -3/2. You come from the right, that's almost like a vertical tangent line, but it's definitely something that's very positive. So you come from the left, you come from the right, you get 2 different slopes. So that's going to be an issue. So definitely 1 is one of the answers. Is there any questions about that so far? The second one we have is, can you guys see that at 2, there's no problem, right? You could look at the slope of the tangent line. You could draw a little tangent line at 2. This tangent line looks something like this. That slope exists. So no problem at 2. At 3, we have an issue. At 3, it's not continuous. And we just looked at a bunch of examples where we said if it's not continuous, it's not differentiable. So if you take a look at what's going on at 4, what does the slope look like on the left side of 4? What does that slope look like to you? That's right, Steve and Ken. I think it's a horizontal line, so that slope looks like 0. When you look at the slope on the right side, that looks like a slope greater than 1, right? So you come from the left, you get 0. You come from the right, you get a slope bigger than 1. Those aren't the same number. So it's not differentiable at 1, at 3, and at 4. Does that make sense? So Steve, I saw that you wrote a comment. You said from 3 to 4. When I say from 3 to 4, that's this horizontal line. The derivative does exist on this horizontal line, but it doesn't exist at 3 and it doesn't exist at 4. But in between it exists because the slope is 0. I hope that makes sense to you.